Good day, everyone. Today I will show you how to calculate sensible heating. Problem statement number one. A high efficiency air conditioning system is designed to cool and dehumidify the indoor air of a large office building. The system conditions 2,500 cubic meter per minute of outdoor air, which enters the system with a dry bulb temperature of 35 degrees Celsius and relative humidity of 70%. Then is cooled and dehumidified to an indoor air of 22 degrees Celsius (dBT) with a 40% relative humidity. Determine the sensible, latent, and specific heat using psychrometric chart. So these are the given. Volumetric flow rate, which is equivalent to 2,500 cubic meter per minute. T1 equals 35 degrees Celsius with an RH of 70%. T2 equals 22 degrees Celsius with a relative humidity of 40%. H1 is equal to 86. H2 is equal to 41. W1 is equal to 0.018. W2 is equal to 0.006. V1 is equal to 0.83. CP is equal to 1.005. HFG is equal to 2260. Solution. The first thing we need to do is convert or to solve the mass flow rate, which is M is equal to V divided by V1, which is equivalent to 2,500 divided by 0.83, which is equivalent to 3,012.05 kilograms per minute. After solving for the mass flow rate, we can now solve for the sensible heat, which is Q is equal to mCp times T2 minus T1, which is equivalent to 3012.05 times 1.005 times 22 minus 35, which is equivalent to negative 39352.43 kilojoules per minute times 1 minute over 60 seconds, which is equivalent to negative 655.87 kilowatts. Now, to solve for latent heat, which is Q equals M HFG times W2 minus W1 is equal to 3012.05 times 2260 times 0.006 minus 0.012, which is equivalent to negative 81,686.796 kilojoules per minute, and divide it by 1 minute over 60 seconds to get an answer of negative 1,361.45 kilowatts. Now to solve for specific heat, which is H2 minus H1 divided by T2 minus T1, which is equal to 41 minus 86 divided by 22 minus 35, which the final answer will be 3.46 kilojoules per kilogram times Kelvin. Now, statement number two, a warehouse HVAC system conditions 2,000 cubic meter per minute of outdoor air. The outdoor air has a dry bulb temperature of 25 degrees Celsius and 60% relative humidity, which is conditioned to 35 degrees Celsius (dBT) and 55% relative humidity before being supplied to the warehouse. Calculate the sensible heat required to condition the air. These are the solutions. First, we need to put the given, which is V equals 2000 cubic meter per minute. T1 is equal to 25 degrees Celsius with a relative humidity of 60%. T2 is equivalent to 35 degrees Celsius with a relative humidity of 55. V1 is equal to 0.84 cubic meter per kilogram and the CP of 1.005 joules per kilogram times Kelvin. For solving the sensible heat, same as before with the formula, you need to find the mass flow rate first to solve for the sensible heat, which would have a formula of V divided by V1, which is equal to 2000 divided by 0.84, which is equivalent to 2380.95 kilograms per minute. Now we can solve for the sensible heat with a formula of mCp times T2 minus T1, which is equal to 2380.95 times 1.005 times 35 minus 25, which is equivalent to 23,928.55 kilojoules per minute times 1 minute divided by 60 seconds, which is equal to 398.81 kilowatts. That is all. Thank you for listening.